All right, number 49. We need to simplify everything inside of the radicals before we can add them together. You can't add radicals unless they have the same stuff on the inside, which is known as the radicand. So what we need to do is rewrite 180y as perfect square factors. Biggest perfect square that goes into 180 is 36 times 5y, plus 245y can be rewritten as 49 times 5y, and 80y can be rewritten as 16 times 5y. Notice they all have these 5y's here. When we square root all the perfect squares, the stuff on the inside will all match up. The square root of 36 is 6, so we're left with 6 times square root of 5y, plus the square root of 49 is 7, so we're left with 7 times the square root of 5y, plus the square root of 16 is 4, so we have 4 times the square root of 5y. They all have the same inside stuff, so you add them all together. 6 plus 7 plus 4, this is going to be 17 square root of 5y for that answer. For 50, we're multiplying radicals. You're allowed to multiply anything times whatever else. For adding, they have to be the same type on the inside, but for multiplication, you just have to remember when you're multiplying the square root of 6 times 2 square root of 3, you just multiply the square root of 6 times the square root of 3. You multiply the radicals, you multiply coefficient numbers separately. So this is going to end up being 2 square root of 18 plus the square root of 6 times 3 square root of 8 would be 3 square root of 48. All right, once I do that, it's time to simplify. Be careful because it's possible that this answer will be on the one of the 4 choices. 18 can be rewritten as 9 times 2. 48 can be rewritten as 16 times 3. We can take the square root of 9. It equals 3. 3 comes out front and gets multiplied by that 2. So it ends up being 2 times 3 times the square root of 2 plus square root of 16 is 4. The 3 is already there, so it gets multiplied 3 times 4 times the square root of 3. There's nothing you can do here with this because these don't have the same stuff on the inside, so you're left with 6 square root of 2 plus 12 square root of 3. For 51, you have to FOIL. 4 times 5 is 20. 4 times square root of 8 is 4 square root of 8. Negative square root of 2 times 5, is negative 5 square root of 2, and negative square root of 2 times square root of 8 would be minus square root of 16. Then we simplify what we can. So 4 square root of 8, I can simplify the square root of 8 by rewriting it as 4 times 2, square rooting the 4. I'll rewrite the rest of the problem and do it over here. And then minus the square root of 16, which is just 4. So combining like terms and simplifying. Let's simplify this first and combine last. The square root of 4 inside can be taken out because the square root of 4 equals just 2, which gets multiplied by the 4 on the outside. So we're left with a 20 up front, and then 4 times 2 is 8. So this turns into 8 square root of 2 minus 5 square root of 2 minus 4. Combining like terms, then you would take these two things here, combine them. 8 square root of 2 minus 5 square root of 2 is 3 square root of 2, and then 20 minus 4 is 16. All right, for 52, it's just asking us what is the conjugate of the expression. Remember, conjugates are kind of like opposite expressions. Only thing that changes is the sign holding the two terms together. If it was a minus sign, it turns into a positive. If it was positive, it turns into minus. So 2 square root of 3 plus 3 square root of 8 would be the answer for number 52. For 53, they want us to find the product, which means answer to a multiplication problem of the expression and its conjugate. So we basically have to take this thing that they give us and multiply it by its conjugate, which is that. Conjugates are cool to multiply because you don't have to FOIL. You just multiply first and last. 2 times 2 square root of x. 2 times 2 is 4, and square root of x times square root of x is square root of x squared, which just equals x. Minus, because it's a negative times a positive, we're going to be multiplying square root of 3y times square root of 3y. Now, some of you have this memorized that when you multiply the same exact radical, basically the answer is just whatever's on the inside, 3y. But really what happens as well is it's 3 times 3 is 9, y times y is y squared. The square root of 9y squared is just 3y. So your answer would be 4x minus 3y for number 53. For 54, we're actually solving equations, which means find the value of x that makes the equation true. These are radical equations. To solve radical equations, you do the opposite of whatever the root is. So for number 54, we first want to isolate the radical by adding 12 to both sides, and we have the square root of x is equal to 12. To undo square rooting, we square. So these cancel, you're left with 144 as the answer. For number 55, you have to isolate the root first. You have the square root of 2x equals -6. Some of you will already realize that there's going to be no solution for this problem because the square root of a number, it's not going to be able to equal to -6. If you go ahead and start solving it by squaring both sides, you'll be left with 2x equals 36. You divide both by 2, you're left with x equal to 18. Now, the problem here with this is when you go ahead and you put your answer back into the original, all right, you're going to get the square root of 36. 2 times 18 is 36, which is 6, and 6 plus 6 does not equal 0. So this one has no solution. All right, 56 through 59 are just simplifying simple radical expressions. When you are simplifying radical expressions, sometimes they're going to be like normal, sometimes they're going to end up being imaginary, so be careful. 24, you rewrite this as a perfect square and whatever else multiplies to be 24. The largest perfect square that goes into 24 is just 4. So 4 times 6. And the reason why I'm dealing with perfect squares is because this is a square root, not a cube root. The square root of 4 is 2, so this ends up being 2 times square root of 6. This negative symbol is inside the square root. The square root of 36, positive 36, just equals 6. The square root of negative 36, you have to remember that the square root of -1 equals I. So this is the same thing as 6i. This is an imaginary number. 58 is also an imaginary number, but 54 is not a perfect square. So you have to think of it as rewriting it as 9 times 6, 9 is a perfect square, and then times this -1 here. The square root of 9 is 3. The square root of 6 stays the square root of 6, and the square root of -1 is I. And then 59, rewrite this as 16 times 3. Square root of 16 is 4. So you have 4 times the square root of 3. Okay, very last page. Now we're looking at complex expressions and simplifying them. 60 requires us to multiply. I know that because there's a number on the outside, parentheses, that means multiply. So 3i times -3, that's going to be -9i. 3i times 2i. 3 times 2 is 6. I times I is I squared. Don't forget, 2 things about imaginary numbers is that the square root of -1 equals I, and also I squared equals -1. So what I will do here in this problem is change I squared into being -1. 6 times -1 is -6. So this is -9i minus 6. And then just switching the order, -6 minus 9i. 61 requires us to FOIL. 5 times 2 is 10. 5 times I is 5i. -4i times 2 is -8i. -4i times I is -4i squared. Combining like terms, simplifying, things like that. 10 stays 10 for now. 5i minus 8i is -3i. And we know that I squared really equals -1. So I replace a -1 in for I squared. This term here, -4 times -1, that's going to end up being a plus 4. So it's going to be 10 minus 3i plus 4. And putting it in the correct format here, 10 plus 4 is 14, and then minus 3i. 62, you will have to FOIL this one, but you first have to understand you have to expand it into 6 minus 7i times another 6 minus 7i. FOIL, 6 times 6 is 36. 6 times -7i is -42i. -7i times 6 is another -42i. -7i times another -7i is going to be a positive 49i squared. All right, well, I squared we know is -1. So I really know that that's 49 times -1. It's going to be a minus 49 at the end. So it's really going to be 36 minus 49 as the constant numbers. That's -13. And then combining these together, that's going to be -84i. And last two questions, simplifying and writing your answer in standard form. You can never have a fraction that has an imaginary number in the denominator, just like you can never have a fraction that has a radical in the denominator, just like you can't have a negative exponent. When you simplify things, you have to just understand what you're trying to do for each problem, which in this case for number 63 is get rid of the imaginary number in the denominator. Because there's two terms here, not one single term, you have to multiply everything by the conjugate. The conjugate of 3 plus 2i is 3 minus 2i. We multiply the numerator and the denominator by that conjugate. We distribute up top. 4 times 3 is 12. 4 times -2i is -8i. Conjugates are cool because you just multiply first and last. 3 times 3 is 9. Minus 2 times 2 is 4. I times I is I squared. And then simplify. I know that I squared really equals -1. So this is really like 9 minus 4 times -1. Which will end up being 9 plus 4, which is 13. So we get 12 minus 8i at the top, and then we get the 13 on the bottom. All right, and then 64, same thing. We are multiplying by the conjugate, so 8 plus 5i over 8 plus 5i. This one requires a little bit more because we have to FOIL since it's 2 terms times 2 terms on the top. 4 times 8 is 32. 4 times 5i is 20i. I times 8 is 8i. I times 5i is 5i squared. The denominator, only first and last because they're conjugates. 8 times 8 is 64 minus 5i times 5i is 25i squared. Times a simplify. So in the numerator, a couple things we can do. 5i squared, I really know is going to be equal to -5. So we're going to be basically taking 32 and subtracting 5. 32 minus 5 is 27. Combining like terms at the top, 20i plus 8i is 28i. Over. I squared equals -1. So this is really going to be 64 minus 25 times -1, which will end up being 64 plus 25, which is 89. Nothing to do to simplify there, so that would be your final answer. And that is all for our honors Algebra 2 final exam. Good luck, everybody.